Section 2.8, use function notation to evaluate formulas. This section is very similar to 2.7, except, see, we're going to be using function notation. That is the new part that we are moving forward to, but we're still evaluating. That means we're finding a value. And this time we're using formulas instead of expressions. So what's the big difference? Remember last time we talked about expressions have no equal sign, equations have an equal sign, and a formula is a type of equation. It gives us a rule for something specifically. For example, volume, how to find the volume of something, what's inside of something is a formula. How to find the area of a surface, that is a formula. So these are specific. So for example, the first one says, evaluate the Poisson distribution formula. So we have the formula. This formula represents the Poisson distribution. And they give us values just like they did in section 2.7 when we were evaluating. And the newest thing we see here is the function notation. This is function notation. Why is this called function notation? That P is just a name. For example, my name is Sandra. So if somebody wanted to call my attention, they would say Sandra. So in this case, the name of the function is P. And the 3 is the value for X, the value coming in. And how do I know it's X? Well, because the original, this is the original, and then this is your instructions, okay? This is your instructions. So they're saying to you, not in words, but in symbols, they're saying, hey, take the Poisson distribution formula, and you know it's the Poisson because it has that P, and substitute 3 for X. And why do you know it's X? Well, because the original had X. Again, what is function notation? Function notation, it includes the name of your function. It can be any letter. Most of the time we use F. In this case, it's P. But it can be any letter that's given to you. Then it gives you the instruction to replace 3 into the given variable. I'm going to erase all of this. I hope you had the opportunity to write it down. And now let's go in and evaluate this function. So the first thing I do is I take my equation and I'm going to substitute all my values. So this is mu, and I know, for example, x is 3. Now I know there's a lot to replace. Okay, I'm going to replace a little bit of time at a time. If you're ready to replace everything, go for it. I'm just showing you a few steps at a time. So here I replaced all my x's with 3's. Now let's keep replacing everything else. Mu has the value of 0.93 or 93 hundredths to the third power times E. E is given to us, and this is a value of 2.71828 to the power of, that's a power, negative mu, 0.93, divided by 3 factorial. Before I go to my calculator, I find that I can simplify things. So I'm going to go and simplify with 3 factorial, and that gives me less opportunity to mess up on my calculator. And that makes me feel better about it. 3 factorial is 1 times 2 times 3, and that'll be 6. And I feel that I'm ready to use my calculator. Remember, let's do numerator at a time, then denominator. Do not try to do everything in the calculator unless you're super expert with all of the parentheses that you need to use. So I have parentheses 0.93 to the third power. I need to get out of the third power. Most of you have to do this on your calculator, so you need to press the arrow to move forward. then times. How can you tell if you didn't press your arrow? Do you see how if I put times, it's going to be kind of like it stays on top? Some of your calculators don't move you out of the exponent, so you have to make sure you do it yourself. And this is going to be to the power of negative, and I'm going to use parentheses here because of that negative. Parentheses are so important on everything. And I'm ready to compute my numerator. My numerator answer is 0.31736222373. Do I need to write all of that down? Absolutely, because I don't want to start rounding very early. Or you can tell yourself to round to maybe to chop 6 places, or 5. 1, 2, 3, 4, 5. That's kind of reasonable. Anything else less than that, like already just leaving 2 decimal places, is unreasonable. Your answer is not going to be accurate at the end. So I have 0.31736 divided by 6. And so we have, now I'm going to approximate. It asks us to round to 4 decimal places, so we're going to write down 5 places. Remember, we need 5 numbers in order to round to the 4. So it's going to be 05289. We're going to underline here. We're looking at this number. These are some little eyes looking. We're looking at this number 9 to make the decision. The question is 9 5 or more? It is. So we add 1. And my answer is approximately 0.0529. What did we have different in section 2.8 versus 2.7? The function notation. That's it. Everything else, I hope that you feel confident saying, yes, I know how to substitute. Yes, I know how to use my order of operations in my calculator to evaluate one side. The only thing we introduced in this section was the function notation. What does the function notation tell you to do? It tells you to replace the given value into the given variable. You go ahead and try example 2 and 3.